Otherwise, October 11th. Alright, I'm feeling very sleepy. Let's hope this one is not too hard. And then we can get it done fast. Find sum of array product. Two integers, m and k, and integer array nums. A sequence of integers is called magical. If the sequence has a size of m, 0 smaller than the sequence smaller than the length, the binary representation of this has k set bits. The array product of this sequence is defined as this. Return the sum of the array products of all valid metrical sequences. So a sequence has size m. So it's m numbers, and then each value is smaller than num star length. Each value is smaller than num star length. And the binary representation of this has k set bits. And the array product of this sequence so you need to have a sequence of 5 numbers. Right, this is a sequence of 5 numbers, and each value is from 0, 1, 2, 3, 4, 5, 0 to 4. Each number. And then we need to have k bits. K set bits. So it doesn't matter so this is just like a position. The values, but the values can be the same, right? The values can be the same. They didn't say it has to be different. Oh, I see. So this is just like the bits, right? So we have 5 bits, 1, 2, 3, 4, 5. I would have 5 bits. If you repeat, right? If you repeat, then it will reduce 1, right? You will reduce 1 bit. So you have 5 positions, you have to have each one is unique. So it has to be 0, 1, 2, 3, 4, 5. So that's why 0, 1, 2, 3, 4. All permutation of this are magical sequences, each with an array product, which is just these multiplied together. 6, 7, 8, 9, 10, 11, 12, 13, 10 to the 13. and then permutation times this, and then mod. Okay, here m equal to 2, so I only have 2, and then k equal to 2, so I only have 2 positions, right? And then k is equal to 2, so they both has to be set, which means also no repeats. And it's a 1, 2, 3, 4, 5. So again 5. So we have 0 to 4. Now it's a choice of 4 permutation. No, it's actually 5 permutation 2, right? So you can have 0, 1, 0, 2, 0, 3. Permutation, yes, 0, 4, right? And then 1, 0, 1, 1, 1, 2, 1, 3. No, 1, 1. 1, 2, 1, 3, 1, 4. And then the same thing. And then each one, you have to find out what's the sum. What's the product? Like 0 and 1. This, and then you do this. M equal 1, so only 1. The n, num's length, so the only value is 0. Right? And then just 28. But m and k and m are not necessarily the same. So you're telling me that m can be, yeah, m should be larger than k. M can be larger than k. M is this. K is the number of bits. So if m is equal to k, that's just the permutation. If m is larger than k, which means like I have 5, but let's say k equal to 3, right? Then what we need is some of them has to repeat, because if we're not repeating, and nums.length, what about nums.length? Nums.length doesn't matter. Nums.length just tell you where it's going to be, the pool that you can choose. So 0 to nums.length minus 1. Those are all the numbers you can choose. And then based on what if nums.length is smaller, which is possible, but like it gotta be not possible for some of them. For example, if I only have 3, that I think is not possible. Oh, then it will be 0. Right? If it's not possible, it's just going to be 0. So yeah, so we do m and k. And if m equal to k, then we check the length. If the length is larger than this, then larger equal to this, then we have something cooking, right? But then we have to figure out how to get basically each one is going to be a permutation, right? Each one is going to be a permutation. And well, actually, if it's a permutation, it's not that difficult, I guess. Huh. So like, it give me the nums, it give me the sequence. You give me the sequence, I can produce the result. You give me the sequence, I can produce a result. Yeah, give me the sequence, I'll produce the result. That is not hard. And the sequence itself is a permutation. It could be a permutation. And that permutation can be a little bit tricky to get. I might need permutation. Hopefully it's something built in that can give me the permutation. That's m equal to k, right? M equal to k, that means everybody's unique. Then you can just pick. Now if m is larger than k, you can still pick, right? It's just you're gonna pick k, right? You're gonna pick k. Oh, that's actually not right, because if you're picking, let's say k equal to, well, k equal to 1 is good. Let's say k equal to 3, right? And you can pick, let's say 0, 1, 2. Okay, that's what you pick. 0, 1, 2. But if you pick 0 again, oh, I guess it's fine, right? So if I go, doesn't matter, if I repeat this again, we just move this one here and this becomes 0, so we still have. So if I'm in this situation, if I pick this again, this is gonna be 0, right? And then move on. And this is going to be 0, move on. We actually reduce 1. Yeah, that cannot happen. So it have to be careful. Huh. Okay. 50. So 50. And most is 30. Object permutation 30. Oh, that is ridiculous. It's not gonna work. Like if it's really 50 permutation 30, you don't have to permute. That's the thing. It's a combination. You get a combination out, and they can just do whatever they want, right? Let's see. What is this combination? Oh, they give you both. So 50 combination 30. Wow, that's a jagged number still. What the hell? think there are two difficult parts. One is this, like if you have m equal to 30, k equal to 30, like both equal to 30, and you have length as 50, what are you going to do? You have to pick 30 out of it, right? You have to pick 30 out of it. I don't know. I think I don't even need this. I can just say maybe 10. $11. 15. That's not exorbitant. Right? So basically, what if I have, 11, 11, and then I got 15 and 15. Right, we have 15. We're just like, oh, this is easy because it's just permutation. Like everyone is the same. No. $20. Now we have 20. 20 pick 15. 20 pick 15 actually is not that bad. Right? 20 pick 15. Because once you pick it, permutation is just the multiplying. That actually doesn't matter. It's the picking part. It's the picking part that is more troublesome. This is only 15,000. That's fine. Maybe 30. 40. 40 pick 20. Yep, let's do 40 pick 20. 40 pick 20. Alright, so I got 40 numbers. And I'll pick 20. Once you pick, permutation is just multiplying with the same. Oh, actually, no, that's not multiplying the same. Because you are doing num sequence multiplying. No, it's the same. Because you pick 20, right? You pick. Those are like indices, right? You pick your indices out. You pick 20 indices out. So you have 40 numbers. You pick 0 to 39. So you pick 20 out. And then you're just multiplying. But the permutation is still the same. The permutation doesn't matter. What matters is indeed the combination. So we just want to see. In an example like this, how long does it take? If it takes a really short period of time, that just means there is a way. There's a way to do it. Which means you don't have to go through all the all the combinations. How do you not go through all the combinations? Because you can pick like 0 to 19. right? And then you can just go, because you can pick any combination. I don't understand. You can pick any combinations. How'd you bisect that? Maybe there's some DP here. Okay, if I include the first one, then it will be 50 choose 19, right? Exclude the first one, 50 19. $50.19 what? There's some. They're this, because you can just pull it together. It's gonna be this times this, time this, plus time this, and then we'll add the first one. This will be multiplied onto what they have already computed. Right? So that's if I include. So basically we can say dp the total length doesn't change, so that's not. What changes is the number that we put in, and the number is m. Right? What is the m value? What does k do? I forgot. K is the number of bits that need to be set. Number of bits that need to be set. Yes. Number of bits that need to be set. Right, number of bits that need to be set. So what we're saying, because the choices are from, and we call n is, let's say, nums.length, right? So the choices are from 0 to n minus 1. Those are the choices. So if I say I need to have m of them, right? M of them, because m is the length of the sequence. So I have m of them, which will form k right, which will form k bits. And now we'll go through them one by one. We can say the first one, if I don't include it, right, if I don't include it, then there'll be no 0. So I need another one. I need an I. Index. Right? So what we want to find is dp mk0. This is what we want to find. But we can say the first one, if I don't include it, that will be dp, mki plus 1. Right? We start from I plus 1 going to the end, but we still need to find m given m, length is m, and I need to find the k bits, right? That's if I don't include the first one. If I include the first one, right? If I include the first one, that means we have 1 bit, right? 1 bit already set. 1 bit already set at that position, right? We already have a bit set. And what we need to do is 1 bit is set. So m is the total option, so we don't have m anymore, right? We have m minus 1, so we don't have any m anymore. And bit, we have 1 bit already. Now here's the thing. Here is the thing. You can set it like if k is smaller than m, right? If k is smaller than m. So there's also another consider is like a current bit. Do I use it to set or do I not use it to set? All right. If k is equal to m, then you have one set, then you will have 1 less to set, and then you'll go to I plus 1, right? So that's the recursion relationship. Yeah, you just have 1 less to set. Yeah, because every number has to be unique, so that actually makes things a little easier. So I think this shall be the situation where m and k are equal. You can use this relationship. And this will be the total, right? But this, whatever it comes out, I'll have to do nums 0. Right, multiplied, because those are just this plus this plus this. So num 0 multiplied by everything, and that value needs to be plus this value, and then we do the mod. This might work, but what if m is larger than k? I have 10, right? I have 10, and then k is only 5. Actually, let's get it even simpler. M is 3, k is equal to 2. So I have 3 positions, but I can only have 2 set bits. how would you handle this? Well, of course, you cannot have everybody set, because everybody is unique. You'll get 3 bits, right? So someone has to be the same, right? Someone has to be the same, so that every time you be the same, you will sacrifice a bit. So 1 bit will be reduced. Okay, so which means this is not possible, right? Like if I have, 3 bits, we'll get 2 out of it. Wait, no, that's possible. Hold on, let me think. Yeah, there is a impossible case, like if that's fine. Like we have more, because we didn't say the length, right? So if the length is smaller, then that's not possible, right? This is not possible. We have only 1, but m equal to 3. M equals 2, which means the length has to be 3, right? The length is 3. Okay. The length is 3, so which means we need to have 3 in the binary representation. Right, 3 binary representation. And then we need 2 bits. So we have 1 set bit. So the 3 are unique, but we only have 1 number, only 1 choice. So all 3 of them have to be the same. And then, but I have to get 2. So this is impossible. This will be a 0, because it's an impossible case. It does not give me an impossible case. Huh? Okay, I don't understand. So sequence has 3. The binary representation has 1 bit. Oh yeah. Wait, no, hold on. But I had 2 bits. Binary representation has 2 bits. Huh? And number length is 1. So the value can only be 0. So it's only 0, 0, 0. Oh, 0, 0, 0 is 2 bits. Holy crap. I accidentally cook up a good test case, but 3 bits. That's not possible. Yeah, that's not possible. Oh, so like this is another hard part where we have to figure out how do we do these bits stuff. Yeah, the M is telling you how many different numbers for the binary representation needs to be, right? And you know if the 2 are, if they're the same, then 2 bits can become 1 bit, and then we'll go to the higher position. In a higher position, we need to check, like if it's the same, then they all get annihilated again, then we'll go to a higher position. So That is something, yeah, I'm not sure. Number of bits. So yeah, what it means is have this number of bits. If I use a bit, right, I can say this bit is unique, so the next one has to be reduced. I don't know, too complicated. Check the answer. Whatever it is, I'll copy and paste and I'll read it tomorrow. I have no interest in figuring this out. This is way too hard. I guess I can figure it out. Yeah, this is just, what the hell? This is indeed what the hell. But I will try. I will try. Okay, even like see the hint. I didn't even check the hint because I'm pretty sure I don't know how this one works. Like, Jesus. This is like way too hard. Again, I do believe if m equal to k, we have an idea. I think it will work. But if m is larger than k, I really don't know. Like how we are going to handle this. Okay, yes, use dp. Let this be the state after choosing I numbers. After choosing I numbers. In indices. The partial sum has produced exactly j set bits. So the partial sum. Well, the thing is that you can probably calculate this. I think I was thinking about it wrong. You don't plan it. You just choosing them. But how do you handle the window of lower order bits from S that have not yet been fully processed? Bits that might later create new set bits when additional terms are added. What? What the actual hell? When was this one first? I can't even figure out the DP state. I'm now more curious. Like, I'm not angry at all. I'm just curious. Oh, you need to do the quick multiplication as well. Oh, hold a second. Quick multiplication, okay. the hell is this? What the hell is this? This is a vector n. A vector of a vector of a vector of a vector. What the hell? Wait, hold a second. It is. It's an array. It's an array of an array of an array of an array. Oh my lord. Oh my lord. This is just... Oh wow. What the hell? Okay, I have never seen anything like this before. Oh my god. A vector. I was like, is this a lambda function? That doesn't look like lambda to me. Like, what the hell is this? It's a vector of length n, of another vector of length m plus 1, of another vector of length m times 2 plus 1. Actually, I don't know what this one is. Of another vector, which is a long, right? That's the final one, which has k plus 1. Oh, and we have 4, 4, 4, 4. Yeah, 4. Wow, shit. 5 levels. My god. 5 levels. Yeah, this feel like a competition level. And oh my god. Hey, the runtime is actually not that bad. Yeah, I think I've seen this word coming up more and more often. Slop. People just calling this slop. But yeah, what else can you do, right? What else can you do when you see problem like this? Yeah, exactly. That's true. They will never ask. But it's fun. I guess to change your mindset, it can be fun. Alright, I think I'll just go through. Oh, let the length. Yes, that's how I was thinking about it too. We sequentially take some numbers, the indices, yes, from this to form a sequence. Suppose there are Ri elements with values equal to... What the hell is t? Yeah, what the hell is t? You never mentioned t before. Oh, that's not t. It's not I. It's rt. There are rt elements with values equal to t. So this is dealing with possibility of repeats. Yes, we know that there has to be some repeats, because if m is larger than k, then we need some repeats. So this is saying if one of the elements inside the sequence with value, but why the value equal to t? Like, what the hell? And then we have, so t is 0 all the way to here. They will equal to this. Hold on. Let me think about this one more time. What the hell are you talking about? Suppose there are rt elements with values equal to t. Or rt is the count, right? So if everybody is unique, then rt is 1. then we just add from 0 to n minus 1. We will add up to m. Yes. That is actually right? Yes, this is... Okay, so RT is the count, and the count can be 0. Right? The count can be 0. So we have n. N is the total pool of number we can pick from. Right? N is the total pool we can pick from. M is the total numbers that we pick out. Right? And then we do this from 0 to n minus 1. So for each number, there can be, you can choose 0 of them, 1 of them, 2 of them, whatever. So there will be a count, and that's RT. And then once you determine the count for every single number out of n, then you add up all the counts, and the counts shall equal to m. Okay, that makes sense. Right? That makes sense. And the number of arrangements of these sequence is, I think this is, hold. What the hell is this? This is this, and this. What is the permutation? Permutation is this divided by this. How do I make sense of the two? I think these two are the number of arrangements. So I think it's doing this in a different way. The number of arrangements, it has to be m, right? Because we have m out. Number of arrangements. I think I can't even like cross the first hurdle. Alright, there's no point of me just blocking the time. I think I might I think I will, I don't know, maybe check people's or go back to, I can't even get through this part. Like this one I can't even get through. No, I'm not following this one. Let's try the solutions. This one looks okay. Okay, it doesn't look as dangerous as the other one, so I guess we'll try this one. What else? Yeah, I'll try this one. All right, that will be it.